Today in class, we talked about writing function rules from tables and graphs. As part of this, we reviewed a few of our key ideas that we've already learned for functions. One is that functions have multiple representations, and today we dealt with 3 of those. We talked about numerical representations, where functions are represented by ordered pairs or by a table with an input and an output. Or they can be written graphically. They can be represented as a picture in a graph form. But both of these are representations of a function. And our goal today was to take those representations of a function and turn them into a function rule, or the algebraic representation of a function where we have an equation. Right? We're turning the function into an equation describing the relationship between the input to the output. So in order to do that, as we discussed, we need 2 things. We need to know the rate of change of the function, which in general we have so far this year called slope, or m, and we need to know the starting value, or more mathematically we call it b, because it is the y-intercept. Right? So we need to know 2 things in order to find the function rule for a function. And once we have those, we can then fill in the equation y equals mx plus b, because we will know m and b. So let's look, for example, at this graph, which is a graph of ticket costs. So the number of tickets determines how much the cost for those tickets is. So if I look to find the rate of change, I could just take 2 points. It looks like I have this point, 212 maybe, and I have this point, 424, and I can calculate the rise. And so this goes up from 12 to 24, so that is a rise of 12 over a run from 2 to 4, that is a change of 2. So 12 over 2 is my rise over run, or I can say the change is 6. So my slope is 6. Now, if I were to follow this pattern down, I can see that this line would continue right through the origin. So my y-intercept is at 0. So knowing this, I could fill in my equation. Y equals, my m is 6x plus my y-intercept would be 0. But of course, we don't keep the plus 0 in a neat equation, so we rewrite it into a standard form of y equals 6x. Here I have an example. This isn't a table, but it is like a table, right? It is a set of points that I could use to write my calculation. Again, the 2 things I need to know are my slope, or my rate of change, and my y-intercept. If I look on any table, my y-intercept is going to be the y value when x equals 0. So x equals 0, y equals 0. So again, my y-intercept is 0 in this case. But the slope is a little trickier to figure out. So I don't have a picture where I can count rise over run, but I can remember my rate of change or slope formula as y2 minus y1 divided by x2 minus x1. For a linear equation, it does not matter which points I pick. So I'm going to go ahead and call this point 2 and this point 1. So my y2 is the y value from point 2, which would be 30. And my y1 is my y value from point 1, or 20. So 30 minus 20. And I have to get my x values in the same order. So my x2 is 3. And my x1 is 2. Simplifying that, I would get 10 divided by 1, or m equals 10. Now to fill in my equation, y equals mx plus b. I have to keep my y, m equals 10. Have to keep my x, plus a y-intercept of 0. But again, in a formal neat equation, I wouldn't keep that plus 0, and I would just have y equals 10x. So if we look at one more example, again, it is a table. And for every one of these, no matter what form it is in, my first steps are to find M and B. So I will do these the same way. My slope, in any time I have a table, I'm going to use y2 minus y1 divided by x2 minus x1. And I can pick any two numbers I want. And it's one reason I really like this example. I don't think I want to pick these fractions. I know how to work with them, and I could, but I'm much more likely to make a mistake if I pick a fraction. So I'm going to go ahead and choose this one as my point 2 and this one as my point 1. I can pick any numbers I want, so I'm going to pick ones that make it easy. So y from my point 2 is -3, minus y from my point 1 is -4. X from my point 2 is 0, and x from my point 1 is -5. So looking at this, I have -3 minus -4. Of course, those minus a negatives I can change to plus. -3 plus 4 is 1. 0 minus -5, I can again change to pluses, and that would give me a 5 for a slope of 1/5. My y-intercept, it's not at the top of the table this time. Another reason I really like this example. My y-intercept is the value when x equals 0. So if I scroll down this table, I see that x equals 0 right here, and the associated y value is -3. So B is -3. Having this information, I can go ahead and fill in my equation. Y equals 1/5 x plus -3. I can, of course, always rewrite that as 1/5 x minus 3 for a final answer.